Next, let's discuss lists in more depth since we use them a lot. If you need to know how many elements are in a list, you can use the built-in len function to get that, like so. Often you also need to slice lists in certain ways to extract values in a given range within the list. The colon is used for this. In this first example, we use :3 to ask for the first 3 elements of the list. And similarly, we can use 3: to ask for everything after the third element, like so. We can also do something like -2: to ask for the last 2 elements of the list. And if you want to append a list to another list, that's what the extend function is for, like this. This will add the list containing 7 and 8 to our original list. And if you want to append a single value to a list, you can use the append function, like so. Another cool thing about Python is that lists can contain just about any type you want. You can even make a list of lists, so let's do that right now. We'll make a new list called y, and make a new list of lists that contains our newly grown x list and this new y list. To retrieve an element of a list, just use the bracket operator like this. Here we're getting back element 1 of the y list. This is 0-based, so y1 actually gives you back the second element, not the first one. y0 would give you the first element, which is the number 10 in this example. Lists also have a built-in sort function you can use to sort the list in place, like so. And if you want to sort in reverse order, you just pass reverse equals true into the sort function. This is also a good time to mention that there are a couple of ways to pass parameters into functions. You can just pass in a list of values like you would in most languages, but you can also pass them in by name. Often, Python functions will have a lot of parameters that have default values assigned to them, and you just specify the ones you care about by specifying them by name. Okay, let's keep going and talk about tuples next. Tuples are a lot like lists, but the main difference is that they are immutable. Once you create a tuple, you can't change them. They're handy for people doing functional programming or for interfacing with systems like Apache Spark that are developed on functional programming languages. We'll do that later in the course. The only real difference is that you enclose tuples with parentheses instead of square brackets. So here's a tuple of the values 1, 2, and 3. We can use len on it, just like we would with a list. You can reference elements in a tuple in the same way that you would in a list as well. Again, it's 0-based, so y2 gives us back the third element of the list, not the second one. You can also make a list of tuples if you so desire. Another common use of tuples is in passing around groups of variables that you want to keep together. For example, the split function on a string will give you back a bunch of string values extracted from that string, and we can assign those values to elements in a tuple as a quick way of naming each one. Look at this example. We have 2 numbers separated by a comma, and we know the first value represents an age and the second an income value. We can extract them right into variables named age and income, like so. Moving on. Another useful data structure in Python is the dictionary. In other languages, you might know this as a map or a hash table. It's basically a lookup table where you store values associated with some unique set of key values. It makes more sense with an example. You declare a dictionary using curly brackets. So let's make a dictionary mapping starship names to the names of their captains. We'll call this dictionary Captains. Now, to create an entry in the dictionary, we use square brackets to specify a key value that we're interested in assigning. So to assign the value Kirk to the key enterprise, we can just say Captain's enterprise equals Kirk. We do the same for the other starships we know about. Then retrieving a dictionary element is done in the same way. Just use square brackets to get back the value you want. So to get the captain of the USS Voyager, we can do it like so. But what happens if you try to retrieve a value for a key that doesn't exist? You get an exception in that case. One way to avoid that is to use the get function on the dictionary. So you see you can retrieve the captain of the Enterprise successfully as it exists in the dictionary. But if we try to get a ship that isn't in our dictionary, it returns the special value none that you can test for and deal with however you want. And if you know that the captain of the NX-01 is Jonathan Archer, you're my new best friend. You can iterate through all of the keys in a dictionary just like you'd iterate through a list like this. For ship in captains, we'll give you back each key in the captain's dictionary and name it ship for you, so we can then print it out like so.